Okay, so today we're going to be factoring polynomials and trinomials. The first step always in factoring is to factor out the greatest common factor, or the GCF. The GCF of a polynomial is the largest polynomial that divides each term evenly. So what we're going to do is we're going to look at all the items inside each polynomial, and we're going to look for the biggest number that goes into every single term. So when I look at this first one, it says 28 plus 42 plus 14. Now, I know I can add them all up, but that's not the purpose of this. Right now, we're just going to figure out what is the largest number that goes into each one of those items. So, for example, like I know that 2 goes into 28, 42, and 14. So 2 is a divisor of all of those. However, it's not the largest number that divides them all. In fact, so does 7, right? So when I look at 28, 42, and 14, I know that 7 goes into all of them. And 7 is definitely larger than 2. But even then, that's still not the biggest common factor, because if I put a 2 and a 7 together and multiply them together, that would be a 14. And 14 goes into 28 twice. 14 goes into 42 twice. And 14 goes into 14 once. So the greatest common factor between those three numbers would be the number 14. If I were to factor it out, I would write something like this. I would say the GCF is 14. And you know what? In this one, they're just asking me for the GCF. I'm just going to write it as 14. I'm not going to actually factor it out just yet. I'm just going to look for the GCF. So 14 is the biggest number. That goes into all numbers. So let's take a look at the next one. If I were to look at 12, 18, and 15, well, 6 goes into 12, 6 goes into 18, but 6 does not go into 15. Neither does 12. So it looks like the largest number that divides into 12, 18, and 15 would be the number 3. All right, here's where it starts getting interesting. As far as numbers are concerned, I want you to notice that both the 4x squared and the 6x, you have a 2 that can go into 4 and a 2 that can go into 6. So I know that 2 is in fact the largest number that goes into both. But as far as the number of x's, the x squared has 2 x's and the x has 1 x. So they share at least one of those x's. So I'm going to say that the x, 2x is the GCF of these ones. So for example, if I were to multiply 2x times 2x, I would get 4x squared. If I were to multiply 2x times 3, that would give me the 6x back. So 2 and x is the largest one. First, you got to find the GCF between the numbers. Then you got to find how many of those variables are being shared. In this case, at most 1x. I can't say that there's an x squared because this one does have an x squared, but this one does not have enough x's, right? This one only has one x that I could take away from. I can't factor out an x squared. All right, using that same idea, we're going to go ahead and find the GCF of these three terms. The first thing I'm going to focus on in the numbers. So I notice that that has a 9, a 27, and an 18. What's the number, the largest number that goes into all of them? Well, that would be a 9. But that's not done, right? Now that I know that 9 goes into 9, 27, and 18, and that obviously that's the largest number because there's not a bigger number that can go into 9 other than 9. Now I'm going to look at how many x's do they share. Well, this one has 5 x's, this one has 3 x's, and this one has 4 x's. So what's the most amount of x's that I'd be able to pull away from each one? The answer would be 3. I can definitely pull away 3 x's from here. I can pull away 3 x's from here, and when I do that, I would be left with no x's, right? And I could pull away 3 x's from here, and when I do that, I'd still be left over with an x. If I try to pull away 4 x's, this does have enough. This one does not have enough, so I can't say that it's x to the 4th. The most amount of x's I can pull out from every single term would be 3. All right, so those are my GCFs. The GCF of the first one was 14. The greatest common factor of my next one was 3. Next greatest common factor was 2x. And then the last greatest common factor was a 9x cubed. All right. We need the GCF in order to do our first step in factoring. So this is always, always, always going to be your first step is find the GCF and factor that out. Sorry, I'm just trying to make it look so that it doesn't look so crazy. So we're going to factor out the following polynomials. In order for me to do that, I need to find the GCF. So let's take a look at the first one. What is the number that goes into 20, 30, and 15? And I want the biggest number that I can pull out, right? Well, between 20, 30, and 15, it looks like that biggest number would be 5. So I'm going to go ahead and say that the GCF is 5. So now I'm going to go ahead and factor out that 5. As far as the variables are concerned, I see that there's two A's here, there's an A here, but there are no A's over here. So I can't say that the GCF is 5A because this does not have an A for me to be able to pull one out. All right, so the GCF is going to be 5. Now, if we're going to factor out the 5, basically what I need to do is I need to go ahead and multiply that 5 back in so that I can get this answer right back. That is to say, now that I'm going to pull out a 5, if I were to pull out a 5, how would I get this 20a squared right back? 5 times what is going to give me that 20a squared? Well, I know that 5 times 4 will give me the 20. And because I don't have any a's over here, I would need 2 a's to match up with that a squared. So that takes care of the first term. If I were to multiply 5 times 4a squared, I should get that 20a squared right back. All right, now I'm going to focus on the middle term. What do I need to multiply 5 by in order for me to get 30a? Well, I know that 5 times 6 will give me 30. 5 times 6 is going to give me the 30, but I don't want just 30. I want 30a. So I don't need this to be just 6. I need this to be 6a. So that when I go 5 times 6a, I'm going to get that 30a right back. All right, so the last one is I need to figure out 5 times what is going to give me the 15. Well, I know that if I go 5 times 3, the answer is 15. And in this case, I don't need any a's because I'm trying to get just a regular 15. So essentially what we're doing is we're factoring, and factoring is almost like the opposite of distributive property, right? It's almost like, hey, this is the answer when you distributed. What was the original thing that you needed to distribute? And we can always check our answers by distributing right back. So here's my check, just to make sure that I did this right. I'm going to distribute that back. 5 times 4a squared, what do I get? I get 20a squared, which is a good look because that's exactly what I was trying to get. If I multiply 5 times 6a, what do I get? Well, I get a plus 38. That looks good because it's matching up. And if I were to multiply the 5 times 3, I do get the plus 15. So it looks like I did factor out that GCF correctly. Let's take a look at the next one. I got 16x cubed plus 8x squared plus 10x, and I want to factor out the GCF. So first, let's figure out what the GCF is. All right, as far as the numbers are concerned, what's the biggest number that goes into 16, 8, and 10? It looks like 8 goes into 16, 8 goes into 8, but 8 does not go into 10, so I can't use the number 8. 4 goes into 16, 4 goes into 8, but 4 does not go into 10. In fact, the only numbers that go into 10 are 10, but that doesn't go into 16. 5, but that doesn't go into 16. And 2. 2 goes into 16, 2 goes into 8, and 2 goes into 10. So 2 is definitely part of my GCF. As far as variables are concerned, I'm going to try to see what's the most amount of x's I can pull out from each one. Well, this one has 3 to give, so I can pull out 3 from here, but I can only pull out 2 from here. So I can't say that it's x cubed, because if I were to pull out 3 x's here, I wouldn't have 3 x's here to pull out. And over here, there's only one of those x's. So it looks like this one is going to be my limitation. I can pull out 1x from here. I can also pull out 1x from here and have 1 left over. And I can pull out 1x from here and have 2 of those left over. So I can definitely pull out at least 1x from each one, and that's the max. So my GCF is going to be 2x. Now that I know my GCF is 2x, now I'm going to go ahead and try to get this right back. So 2x times what is going to multiply to give me that 16x cubed right back. So 2x times something is going to give me 16x cubed. Well, I know 2 times 8 is going to give me the 16. And right here I have an x, but I'm trying to get an x cubed. That means I'm going to need 2 more of those x's, so I'm going to put an x squared here. That should give me this 16x cubed right back. All right, I'm done with the first term. Let's move on to the second term. I'm trying to get an 8x squared. Remember, I'm starting off with a 2. 2 times what is going to give me that 8? Well, that's got to be a positive 4. And as far as the variables are concerned, I already have 1x, but I'm trying to get 2 x's here. So if I already have 1x and I'm trying to get an x squared, that means I'm missing one of those x's. And then for the last one, I'm trying to get the 10x, and again, I already have 2 x's here. 2 times what is going to give me that 10? Well, 2 times 5 is going to give me the 10. As far as the x's are concerned, I already have an x, and I'm trying to end up with just an x. So I actually don't want to put any x's. If I put an x here, then it'd be x times x, and that's going to give me an x squared. I don't want an x squared. I want a regular x. That means I just leave it like this. 2x times 5 is going to give me that 10x. I don't need to replace any more x's. And that should work, okay? Again, the first few times you do this, you really should check just to make sure. The way you're going to check is you're just going to distribute it right back and make sure that this works. 2 times 8 is going to give me a 16, and an x times x squared is going to give me an x cubed. Remember, when you're multiplying, you add the exponents up at the top, and that's why I got 3 x's over there. When I multiply the 2x times the 4x, let's see, 2 times 4 is going to give me a positive 8. X times x is going to give me an x squared, and that's exactly what I wanted to get. It looks like that's working out as well. And then the last one, I'm going to go ahead and distribute. I'm going to get 2x times 5. That's going to give me a positive 10x. And that's exactly what I was looking to get. And it looks like this is the factored form of this polynomial here. All right, let's get a little bit more complicated. I got a 10, a 50, a 20, and a 90. As far as the numbers are concerned, it looks like the biggest number I can pull out would be a GCF of 10. And as far as the variables are concerned, this one has 4x's, 3x's, 2x's, 1x. The most amount of x's that I can pull out from each one would just be that 1x. This is the one that's limiting me here. I can only pull out 1x from here. I can definitely pull out more over here, but it doesn't matter. This is the one that's going to cause me trouble. So I can only pull out 1x max from each one. Now that I have that, let's go ahead and write it. Let's see. So I'm going to write the GCF in the front. I'm going to pull out a 10x. What do I need to multiply 10x by in order for me to get 10x to the fourth? Well, the 10 is already there. I don't have to worry about the number. I have an x, and I'm trying to get to x to the fourth. That means I need 3 more of those x's. So I'm going to write this as x cubed. All right, for my second term, I'm starting off with a 10. What do I need here in order for me to end up with 50? Well, I would need a positive 5. And because I already have one of those x's and I'm trying to get to 3, that means I would need 2 more of those x's, so I'm going to write this as x squared. All right, now I'm down to the third term. I'm starting off with a 10. I'm trying to get to a negative 20. If I'm going to jump from 10 to negative 20, I need to multiply that by negative 2. As far as the x's are concerned, I already have an x, and I'm trying to get to an x squared. So that means I need 1 more x, so that way I can end up with 2 of them. I'm going to write it with an x. And then for the last one, I'm starting with the 10, and I'm trying to get to a negative 90. 10 times what is going to give me a negative 90? That would be a negative 9. As far as the x's are concerned, I already have an x, and all I want is an x. So because I already have the x, I don't want any x's here. I'm just going to leave it as a minus 9. And that should be the factored form of the top term, the top polynomial that I have up there. And again, if you wanted to check, you could do that really quickly. I'm going to run through this really quick. Let's see, 10x times x cubed, that is 10x to the fourth. 10x times 5x squared, that is plus 50x to the third. 10x times a negative 2x, that's going to give me a negative 20x squared. And then 10x times negative 9, that's going to give me a negative 90x. I checked to see if that's the original thing that I started off with, and sure enough, it matches perfectly. So I know that this is, in fact, the factored form with the GCF pulled out. All right, let's take a look at the next one. All right, as far as numbers are concerned, ooh, it always kind of troubles me when those numbers get kind of big. Let's see, 24. There's a lot of numbers that go into 24. 1, 2, 4, 6, 8, 3. Forgot 3. I think I forgot 3. 12 and 24. 24 goes into 48 as well, but 24 does not go into 40. What goes into 40? 1, 2, 4, 5, and 10, and 8. It looks like 8 is the biggest number that works for all three numbers so far. 8 works here, 8 works here, 8 works here, and 8 works here. So I think 8 is the one we're going to go with. 8 is the largest number that goes into all of those. As far as, let me write that, the GCF equals 8. As far as the R's, what's the maximum amount of R's that I can pull out? This one has 6 to give. This one only has 3. This one has even less. This one has 2. And then this one has 4. So I'm going to go with this one. This is my limiting one, right? The most I can pull out is 2. This is my smallest number of R's. So I'm going to be able to pull out 2 R's. I'm going to start off with an R squared. So I think the GCF is 8R squared. Let me go ahead and factor that out. So I'm going to pull out an 8R squared first. And now I need to get everything back. 8 times what is going to give me the 24? That would be a 3. And R squared, I'm trying to get to R to the 6. That means I need 4 more of those R's. So I'm going to put R to the 4th. I'm done with the first term. Let's move on to the second term. Second term, 8 times what gives me 48? That would be a positive 6. R squared times what gives me an R cubed? Well, I'm missing one of those R's, so I'm just going to put a single R there. That takes care of the second term. Moving on to the third term. 8 times what gives me negative 40? That would be a negative 5. And because I'm trying to go from R squared to R squared, well, I already have the R squared, so I don't need any R's right here. And then for the last one, from 8 to negative 24, you need to multiply that by negative 3. And if you're going to go from R squared to R to the 4th, that means you need 2 more R's, so you're going to put R squared. And again, if you were to check it, and this is going to be the last time I'm going to run this check, guys. If I were to check it, I would just multiply this out. 8 times 3 is 24. And then R squared times R to the 4th is R to the 6th. 8 times 6 is positive 48. And then R squared times R will give me an R cubed. 8 times negative 5 would be negative 40. And because I already have an R squared and there are no more R's, I'm going to be left with an R squared. And then 8 times negative 3 is negative 24. And then the R squared times the R squared will give me an R to the 4th. I'm going to check to make sure that they all match. This match with this, that match with that, this match with that, this match with that. So it looks like I did do this correctly. Okay. Yeah, I'm not going to run the checks anymore. I'm going to leave the checks up to you. We're going to try to do this a little bit quicker. As far as numbers are concerned, let's take a look at this one. What goes into 2, 3, and 8? There is no numbers besides the number 1 that goes into 2, 3, and 8. What about variables? Can I put out any variables? Well, I can pull out 3 m's, 2 m's, and there are no m's here. So, guys, this one doesn't have a GCF. So the GCF would be 1. If you factor out a 1, it's just going to stay the same. So this one, we are done. Whenever the GCF is 1, there's really not much you can do with that one as far as factoring out the GCF. So let's take a look at the next one. The numbers. Let's worry about the numbers first. What goes into 9 and 6? Well, that would be the number 3. And as far as variables, how many p's can I pull out? Well, I can pull out 3 from here and then 2 from here. This is the one that's going to be limiting me, so it's going to be p squared. Now that I know my GCF is 3p squared, let's go ahead and factor it out. I'm going to write 3p squared. How do I get it back? Well, let's see. 3 times what gives me 9? That would be a 3. And because I'm going from p squared to p cubed, that means I would need another p. I'm done with the first one, and now I'm going to go to the next one. 3p squared times what is going to give me 6p squared? Well, 3 times 2 is going to give me the 6. And because I already have the p squared, I don't need anything, so this would be done right there. Let's go ahead and worry about our numbers first. What goes into 9, 24, and 15? 3 goes into all those numbers. 9 also goes into 9, but 9 does not go into 24. So it looks like 3 is the largest number that goes into all of them. As far as variables are concerned, this one has an r squared. That has an r to the 8th. This does not have any r's. You cannot pull out any r's from this. This is the one that's going to limit you. So my GCF is just the number 3. As far as factoring it out, I'm going to write this as 3 parentheses. Let's go ahead and get it back. How do I get this back? This is going to be 3 times what gives me 9. That would be a 3. And because I need all those r's, I'm going to write it as 3r squared. Done with the first term. 3 times what is going to give me 24? Well, that's easy. That's just a positive 8. And because I don't need any r's, that one's done. And then the last term, I'm going to go 3 times what gives me 15r cubed? Well, 3 times 5 gives me the 15. And because I don't have any r's and I'm trying to get to r to the 8th, I'm going to need all 8 of those r's. And that one would be done. Sorry, guys. I wish I knew what's going on with the blurriness, but it is what it is. Okay, let's go ahead and go on with this one. As far as the GCF, let's see, numbers 5, 2, and 5. Nothing goes into 5 and 2 except for 1. As far as variables are concerned, well, there's 10 R's, 8 R's, 7 R's. It looks like the 7 R's is going to be my limiting factor. So the most I can pull out is 7. I can pull out 7 from here and I'm still left with 1. I can pull out 7 from here and I'm still left with 3. So the GCF here is going to be r to the 7th. If I factor out an r to the 7th, how do I get this back? Well, remember, we're going to imagine that there's a 1 in the front. So 1 times what is going to give me 5? That's a 5. Because I already have 7 r's and I'm trying to get to 10, this would be r cubed. Let's get that middle term. I remember there's no number here and I'm trying to get a 2. That means I definitely need a 2. And because I already have 7 r's and I'm trying to get to 8, then I need another r. Then on this one, again, I have no numbers here. I'm trying to get a 5r to the 7th. So I definitely need a 5. Because I have 7 r's here and this one has 7 r's, I don't need any more r's. So that's as far as we need to go. All right, on the next one, I'm going to look for my numbers first. Let's see, between 2 and 2, it looks like the GCF is 2. As far as factoring out that 2, let's see, I'm going to take the 2 out. I'm trying to get from a 2 to a 2b. Well, I already have the 2. I'm going to go ahead and write that I need a b. That way, when I distribute this, right, I get 2 times b is 2b. That's going to work, all right? Now, here's the mistake. The mistake would be for you to say, oh, I already have the 2. I don't need anything here to get the 2, so I'm just going to write it like this and then close my parentheses. Remember, if you don't put anything here, then there's nothing there to give me the 2 back. So I need like a placeholder here. 2 times what is going to give me 2? Well, that means I need a 1 to kind of hold its place. That way, when I distribute, 2 times b gives me the 2b. And then 2 times 1 gives me the 2. And I don't lose that 2 at the end. So I definitely need a plus 1 at the end. All right, here is the rule. Let's put a thought bubble on this. This is going to be extremely important. If your number starts with a negative, you need to factor out the negative. So right here, I'm going to write factor out the leading negative. What that means is if it starts with a negative, you need to factor it out. That is so important, and it's a rule that students forget all the time, and it's what causes so many headaches down the road. So if I see I'm going to point that out over and over and over. If you see a leading negative, you need to factor it out. That is to say, if it starts with a negative, that negative needs to get factored out. So I just told you GCF, because it starts with a negative, you need to factor it out. As far as the numbers are concerned, let's see, I see a 5 and a 10. 5 goes into both of those, so I'm going to factor out a negative 5. And as far as x's are concerned, this has a 9 x's and this has 1 x. This is going to be your limiting one. So let's go ahead and factor out that singleton x. Okay, Now that I know my GCF is negative 5x, let's go ahead and factor it out. I'm going to write negative 5x in the front, parentheses. I'm starting with the negative 5, and I'm trying to get to negative 5. So I already have it. I don't need any numbers. As far as the x is concerned, I'm starting with an x, and I'm trying to get to x to the 9th. That means I need 8 of those x's. So it's going to be x to the 8th. All right, on the next one, I'm starting with the negative 5, and I'm trying to get to negative 10. Negative 5 times what is going to give me a negative 10? That would be a positive 2. Negative 5 times positive 2 is in fact negative 10. Because I already have an x and I'm trying to get an x, I don't need to add any more x's. This is done. And again, you can run your check, make sure you end up with this exact same thing. And of course, when you check it, this is going to work. All right, guys, we have 2 more problems and then we'll call it quits for today. Wow, look at this crazy thing here. It makes it even more crazy with all the extra stuff going on there. All right, I see a negative 18 x cubed y squared, 36 x squared y squared, negative 48 x squared y. Numbers. What's the biggest number that goes into negative 18, 36, and 48? Well, negative 18 goes into 36, but 18 does not go into 48. So let's try to make it smaller. What about 9? 9 goes into 18, 9 goes into 36, 9 does not go into 48. What about 6? 6 goes into 18, 6 goes into 36, and 6 does go into 48. So it looks like my biggest number that goes into all of them is going to be an 8. The other thing, I should have started off with this. Oh my goodness. This is starting with the leading negative. Factor out the leading negative. I need to factor out the leading negative. So when I start my GCF, I know it's going to be negative something, okay? And we said it was negative 6, right? So negative 6 goes into all of that. As far as variables are concerned, let's worry about our x's first. There's 3 x's here, there's 2 x's here, and there's 2 x's here. So it looks like the most amount of x's I can pull out from each one would be 2. I can pull out 2 x's here and be left over with 1. I can pull out 2 x's here and be left with nothing. And I can pull out 2 x's here and be left with nothing. Okay, so I can pull out an x squared. But not only that, as far as the y's, this has a y squared, so there's 2. This has a y squared, so there's 2. This only has one y, so there's 1. So it looks like this is the limiting one. So I can pull out only one y. Because this problem is going to be a little bit ugly, let me go ahead and factor it down here, okay? So let's see. Negative 6x squared y is what I factor out. How do I get this back? Well, negative 6 times positive 3 is going to give me a negative 18. I have 2 x's. I'm trying to get to 3 x's. That means I need another x. I have 1 y. I'm trying to get to 2 y, so that means I need another y. Whoa, that was wrong. Did you see what I did? Sorry. Didn't mean to mess you up. Negative 6 times negative 3 is a positive 18. I'm trying to get a negative 18. That means this needed to be a positive 3. Sorry about that. Did not realize it. Glad I caught it. All right. Moving on. For the next one, I'm starting with the negative 6, and I'm trying to end up with a positive 36. That means I need another negative 6. So when I go negative 6 times negative 6, it gives me that positive. So that's going to give me the positive 36. I'm with an x squared, and I'm trying to get to an x squared. I don't need anything there. I'm with a y, and I'm trying to get to a y squared. That means I still need another y. And then for the last one, I'm trying to get from a negative 6 to a negative 48. I'm going to need a positive 8 to do that because negative 6 times positive 8 gives me the negative 48. I'm trying to go from an x squared to an x squared. Well, I'm already there. I don't need anything. And I'm trying to get from y to y. I'm already there. I don't need anything. That's as far as we need to go. We're going to go ahead and close that out. And that looks good. Again, you can always check your answer by distributing it back and seeing if it actually matches up. All right, down to our last one. Between 12, 8, and 16, first of all, I This number right here is positive. This number is negative. Do I need to factor out the leading negative like I did over here? The answer is no, because even though this is a negative, it's not a leading negative. You only factor out the negative when it's the first number that's negative. And that first number is positive, so I don't need to factor out any negative there. So the GCF, I'm not going to factor out a negative. Between 12, 8, and 16, it looks like the biggest number that goes into all of them would be the number 4. As far as variables are concerned, this has 3 A's. This one has 2 A's. This one has 2 A's. What's the most I can pull out? That would be 2 A's, or I'm going to write as A squared. As far as b's are concerned, this is a b squared, this is a b squared. This one doesn't have any b's to give away, so I can't pull out any b's. This is the one that's restricting me, okay? All right, so I already know that the GCF is 4a squared. Let's go ahead and write that in the front. Let's get this stuff back. Let's see, from 4, how do I get to 12? I need a 3. From a squared, how do I get to a cubed? I need an a. And from having no b's to having a b squared, that means I need both of those b's. Well, I'm going to write it as a b squared. All right, that takes care of the first term. For the second term, I'm trying to get from 4 to negative 8. That means 4 times negative 2 gives me a negative 8. I'm trying to get from an a squared to an a squared. I don't need any more a's. I'm good there. And I'm trying to get from no b's to having a b squared. That means I need both of those b's. I'm going to write b squared. And then for the last term, 4 times what gives me 16? That's going to give me a positive 4. How do I go from an a squared to an a squared? Well, I'm already there. And as far as the b's are concerned, I don't have any b's, but I don't need any b's. So I think that's it. I'm going to close that up. And that takes care of the notes for today. As always, feel free to ask if you have any questions.